There are several key advantages to using the metric system. One is that metric prefixes can be used with absolutely any measurement types that you'd like. For instance, the base unit of distance is the meter, and so we can use kilometers, millimeters, etc. to express distances significantly larger or smaller than a meter. Similarly, we can express volume as liters, milliliters, microliters, etc., or time as milliseconds, nanoseconds, and so forth. Any measurements that you can think of can utilize metric prefixes in the manner discussed in this video. There are other prefixes besides the one outlined on this table, but this table does represent the most commonly used and are the ones that you should memorize for the purposes of this course. The other chief advantage to the metric system is that prefixes utilize powers of 10 as the conversion factors. For instance, a kilometer is equal to 1,000 meters, while a centimeter is equal to 1/100th of a meter, and so forth. To use the metric system, we're going to think of this line right here as our basic baseline. Any prefix that is above this baseline represents a measurement that is larger than our base unit, while any prefix that is below this line will represent a measurement which is smaller than our base unit. There are a couple different ways to go about converting between base unit and prefixes. One of those is to use the prefixes as conversion factors. As you can see here, for instance, 1 megaton is equal to 10 to the 6th tons. 1 nanometer is equal to 10 to the negative 9th meters. And so we can set those up as conversion factors in order to convert between one or the other. Let's take a look at some examples. A watt is a unit of electrical energy. Quite often, when we're talking in terms of watts, we're dealing with very large numbers, for instance on your electric bill. And so it may be more convenient for us to think in terms of gigawatts. For instance, if we have a value of 1,210,000,000 watts, and we want to convert that over to gigawatts, we set up our conversion, and we see that our multiplier for giga and our conversion is going to be 10 to the 9th. This means that there are 10 to the 9th watts in every 1 gigawatt. And so to set up our conversion, remember when using dimensional analysis, you always want to set the unit that you're looking for up on top. And so we said that every 1 gigawatt has 10 to the 9th watts. And so we set that up, we convert it through, and we come up with a value of 1.21 gigawatts, or roughly enough energy to send your DeLorean back to 1985. To look at another example, quite often if we're talking about the time of chemical reactions, we're dealing with very small fractions of a second. So maybe we have a reaction that occurs in 0.00000000943 seconds, but we want to think about that in terms of nanoseconds. So again, we set up our conversion, and we multiply that by our conversion for nano. There are 10 to the 9th nanoseconds in every 1 second. Multiply that through, that gives us a value of 9.43 seconds. If you're converting between two different base units, for now, as you are getting used to using these prefixes, I recommend that you convert to the base unit first and then convert to your desired prefix. For instance, if you need to convert between kilograms and micrograms, I recommend first converting kilograms to grams with the appropriate prefix, and then from grams to micrograms. Let's look at an example. If we have a very small number of kilograms, we will first use our appropriate prefix in order to convert to grams. So there are 10 to the third grams per 1 kilogram. And then we'll use the appropriate prefix to convert over to micro. Every 1 microgram contains 10 to the negative 6th grams. This would give us a value of 0.543 micrograms. As you are getting better and better with dimensional analysis through this semester, you'll see that you can do both of these in one step. First, we use our conversion factor to convert to grams, and then we can simply set up our next conversion factor to convert over to micrograms. And we'll get the same answer. Taking a look at another example, suppose we have a distance of 9,750,000,000 micrometers, and we want to convert that over to kilometers. And so we set up our conversion. And using our appropriate prefix, we see that there are 10 to the negative 6th meters in every 1 micrometer. And then we want to convert to kilometers. And we see that for every 1 kilometer, we have 10 to the 3rd meters. Which ultimately gives us a value of 9.75 kilometers. Another way to think about metric conversions is by simply moving the decimal point rather than setting up conversion factors. This table is similar to the last one that we looked at, and here what we're going to see is that any time we are moving up the table, we are going to move our decimal point to the left. And any time that we're moving down the table, we're going to move our decimal point to the right. In other words, if we're converting from a base unit, such as liters, to a prefix such as microliters, we're moving down our table, and so our decimal point would move to the right. If we are moving maybe from centimeters to kilometers, we're moving up our table, and so our decimal point would move to the left. You know how far to move the decimal point, or how many places, by looking at the exponents in our multipliers. For the purposes of this, ignore the signs on the exponent and simply move the decimal point by how many numbers is shown. For instance, if moving from a base unit to kilo, we would move our decimal point 3 places to the left. If moving from our base unit to centi, then we would move our decimal point 2 places to the right. If converting in such a way that you're going through the base unit, for instance, maybe we're going from megahertz to microhertz, then we see that we're moving down the table, so we're going to move our decimal point to the right. From mega to our base unit would be a movement of 6 decimal places. to micro would be movement of another 6. And so in that case, we would move a total of 12 spaces to the right. Let's look at a few examples. If we want to convert 456 milliliters to liters, we see that we are starting at milli, and we're moving to our base unit. So we're moving up the table, so our decimal point is going to move to the left. Our exponent for milli is 3, moving to our base unit. And so we move our decimal point 1, 2, 3 spaces to the left for a value of 0.456 liters. When I'm converting in this way, I really do like to leave the little humps here like you've seen me do above. This way, if I run out of numbers, I know I have to go back and put in a 0 wherever I left a little hump. For instance, let's say our decimal point started here. If we had 4.56 milliliters, converting to liters, it's the same conversion. We're moving our decimal point 3 places to the left. So we go 1, 2, 3. There's our new decimal point. So I have to go back and put in zeros here for a value of 0.00456 liters. If we have a wave with a frequency of 0.000009 megahertz, and we want to convert that over to hertz, then we see that our conversion from mega to hertz, we're moving down the table, so we'll move our decimal point to the right. Our prefix is a 6, so we'll move it 6 places to the right. 1, 2, 3, 4, 5, 6, for a value of 9 hertz. Again, if you're converting from one prefix to another, we simply add the exponents to see how far to move the decimal point. Remember, we're going to ignore the sign of the exponent in these cases and just add the absolute values. For example, if we want to convert 0.00063 kilometers to centimeters, then we see at first we're moving down the chart. We're moving from kilo to centi. So we're moving down the chart. Our decimal point will move to the right. In order to get from kilo to our base unit, we move 3 decimal places. And then to get to centi, we'll move another 2. So we're going to move a total of 5 decimal points to the right. 1, 2, 3, 4, 5. For a value of 63 centimeters. For a final example, let's say we want to convert 456 million micrograms over to kilograms. We see that first moving from micro to our base unit will be 6 decimal places. Then from our base unit to kilo is another 3 decimal places, so a total of 9 decimal places. We are moving up the chart, and so our decimal point is going to move to the left. And so we want to move 9 decimal points to the left. So we're starting right here. We move 1, 2, 3, 4, 5, 6, 7, 8, 9 for a value of 0.456 kilograms. Practice some conversions on your own. At this point, pause the video, do out the conversions, and then restart the video in order to check your answers. Pause the video now. Here are the answers. Hopefully you got them right. If you did not, go back, try to see what you did wrong, and correct your mistakes. If you need more help with metric conversions, be sure to come see me or go to the Learning Commons and work with a tutor. This is a skill that we will be using all through the semester. It is very important that you know how to convert using metric prefixes. Thank you very much.